and welcome to this talk on integrating LLMs with external tools. Um, so this is a really exciting time to be working in the field of NLP with so many uh, new models, new tools, new techniques being introduced just about every week. In fact, almost 90% of my presentation today is made up of content that didn't exist until like a few months ago. So the pace of progress is pretty furious. Um, so just a little bit about me. So I'm a co-founder at Bedrock AI, a Toronto-based fintech startup. We have been using LMs slash LLMs ever since the launch of our startup, and we have been deploying them in production right from the beginning. Um, so we are now on our third generation of models, which closely uh, matches the progress and evolution in large language model development over the years. I also had the opportunity to work at Big Science, where we the organization that built Bloom, the large language model, and I work specifically on the detecting PII on the pre-training data. I also happen to be writing a book on large language models, and this particular topic is so there is one specific chapter in my book that deals with the topic that we are going to talk about. So here's the agenda for today. So at first, I'll just set out uh, providing a lay of the land, so to speak. What do we have out there? And then we'll try to push the boundaries of what is possible given today's uh, capabilities of language models. We'll talk about the different ways in which you can integrate external tools with the language models. And then I'll give a few specific examples, including OpenChatKit, LlamaIndex, which used to be formerly called GPT Index, LangChain, which might be the most important um, Python library in current times, task decomposition. So how to break down a complex task into more manageable components, and then also a little nod to GPT-4 and how we can go forward from here. Um, so, so let us start with a timeline, and this uh, is what I personally think are major milestones in this particular field. So it all started in June 2020 when GPT-3 came out. As you all remember, there was a lot of hype about it. And I think at that time, I also recall someone saying uh, the US presidential debate later in 2020 will have an entire section just debating about GPT-3 and its effect on society because it's going to change the world forever. Of course, we now know what happened in the presidential debates. I'm not even sure if either Biden or Trump even knew about the existence of GPT-3 at that time. But overall, GPT-3 was still, despite its flaws, it was still a phenomenal improvement over what existed before. Um, so in March 2021, we had the first open source um, model come up. So prior to that, I was a little worried that uh, language model research is now only something that big tech labs can afford. But then Eleuther AI, a community research organization, came up with GPT Neo. So the model here is a 2.7 billion model. I'm not sure many would classify it as an LLM today, but still it was a landmark effort. in October 2021. So this was when I, who was so far skeptical, became a true believer. So this turned me into an AI optimist. So basically, when we started looking at instruction tuning models, so instruction um, tuning turned out to be the superpower, the technique that you need to turn a language model that behaved like a unruly teenager into a well-grounded adult that follows instructions you give it. And this, so there was this T0 model that was built, I guess, by big science. And when I first used it, I had a religious experience. So this was when everything changed for me, and I realized that we at Bedrock AI we had to get started on working on incorporating instruction tuning ASAP. Uh, so then you had a few months later, OpenAI came out with the Instruct-GPT paper that introduced how you can use reinforcement learning and human feedback to align your language model to behave more in tune with human preferences. Of course, we found out later that the reinforcement learning model was not made public until sometime in October or November when GPT 3.5 came out. And then, Chat GPT that um, went mainstream with its easy to use user interface. And just this week or last week, we had OpenChatKit. That is a open source version of ChatGPT, which I'm excited to talk about later in the presentation. And also yesterday we had GPT-4. So what are the strengths and limitations of these large language models as we see it today? So I don't think anyone can talk about this in a very authoritative fashion because evaluations are still pretty limited, and everyone is still figuring out the limits of what is possible and what is not. But these are purely based on my personal experiences working on uh, the both the open source models and models from Cohere or OpenAI, etc. I think when you look at strengths, it is clear that it's really good at following instructions and at query understanding. One thing I have noticed is like especially when the more recent models, they are really good at understanding the intent of your query. Um, as an aside, I'm surprised to see people interacting with ChatGPT in very formal English, like even using the word please, um, because that it is not necessary. And I don't even use grammatical English. I just use keywords. So for example, if I have to ask ChatGPT for a vegan recipe, I just say vegan vegan recipe with carrots. I say vegan recipe carrots rather than an lengthy sentence. Of course, if you are using the API, you save a lot of tokens this way too. But anyway, uh, it's also really good at all the low-level NLP tasks which we used to spend years on building specific models like named entity recognition or constituency parsing, dependency parsing. And it is phenomenal at code generation. Personally, it has reduced uh, my coding time by about 55-60%, I would say. And it's also great at summarizing and rephrasing. So I have an asterisk here because there is still the hallucination problem and the factuality problem that um, prevents this from being really something that you can call it as a full-fledged strength. But just looking at this, you can see that I think overall, the large language models of today are really good at um, accepting an instruction from the user, and then once it gets the answer, it can generate or phrase the answer or summarize it in a really neat way. So it's a really nice front end to any software system or a knowledge base. But what are the limitations? So I put reasoning here as a limitation because, you know, um, going back when ChatGPT came out, I wrote a blog post. That blog post has not yet been published, and the reason is because every day I use it, I'm less and less impressed by its capabilities. I still think it is really good and it will unlock billions of dollars of opportunities, but it still has plenty of flaws. And I think uh, because a lot of its flaws, I see it in the reasoning department. I think it's still not there, and I think it's a limiting factor for a lot of use cases. It's of course doesn't have grounding and weak in factuality. It's weak at complex math, and also it is not. So its knowledge is limited only to the cutoff of the training data. So if it was trained only until August 2021, it doesn't know anything after that. But taking each of these, so for example, complex math, um, we know how to do that outside of an LLM. We know how to, you know, extract factual information from authoritative documents. So the question then is, why not allow those external tools to do all the heavy lifting and let the language model just focus on what it is strong at? So what are the different tools that you can use this way? So we can have a language model interface with a Python interpreter, with a search engine, with different kinds of data stores, databases, knowledge graphs, APIs. And someone recently told me, when I was talking about certain limitations, dude, just hook up a search engine, problem solved. But all these are good, but do they really solve the problem? So there is a word of caution here for, I guess, all the exuberance that we see in the ecosystem today. I remember, an analog can be drawn with the self-driving cars. So way back in the early 2000s, in 2012, people were predicting that there would be self-driving cars uh, everywhere by the end of this decade, but that never happened. And one thing is that I guess humans underestimate or fail to recognize that for a lot of applications, being at 99% is not good enough, especially if your failure cases are unpredictable. Sometimes, you know, for example, in the self-driving car case, even if the system made good decisions 99% of the time, or even 99.9% of the time, it's not worth. It's still not production ready, because you have to ask these important questions: what is the cost of a false positive? What is the cost of a false negative? And I think we will slowly see that even for a lot of NLP applications, we'll run into this hurdle where even if the language model is good 99% of the time, the 1% of the time where it fails very awkwardly can be a deal breaker in productizing that problem. So let's push the boundaries of what is possible today. And I want to present two use cases, and we'll see if we can actually fulfill these tasks given today's tools and technologies. So the first use case is, can an LLM answer a question of this form? Who was the CTO of Apple when its share price was at its lowest point in the last 10 years? So in this case, how would a language model solve this, answer this question? So it has to break down the task into manageable components. It first has to break down, it needs to know it's today's date, and then it needs to know what does 10 years in the past means, what is that date, and then it needs to find out what the lowest share price in the last 10 years was, in that date range. And then when it gets the date when the share price was the lowest, it has to find out, let's say, the list of CTOs of Apple and figure out on that particular date who was the CTO. So it seems like a pretty tall order, but as we will see later, it's not really that far beyond our reach. The second use case, so this is something that is, I guess, I faced it myself recently. So one thing is I'm not a Canadian citizen, so that means that I can't transit via the US because I don't have a transit visa, and I also can't do self transfers because for most countries in the world I would need a visa. Therefore, I'm restricted to only a few flights. So if I go to a flight search engine, I find it hard to filter out because I have to manually filter out results that are not relevant to me, and there are no predefined filters that I can, just with a click of a button, leave it out. So I thought Bing Chat would be a useful thing for this. So find me flights from Toronto to Bangalore, flying out June 27, returning on August 12, without transiting via the US and without involving a self-transfer. And the idea here is that the language model would, call either an API or make a web query, and then it would, after getting the results, it would filter out, you know, listings that involve transiting via the US, and it would see if anyone involves a self-transfer. So yeah, let us now see how something like this can be made possible. So talking about tool integration paradigms, so there are two, I would say, main approaches. There's the lean approach where you have a particular user query, and then you send it through a sequence of external API or database calls, and then you get the output that you get is fed to a language model, and the language model just takes the output and synthesizes a good answer for you that looks coherent and so on. Here the heavy weightlifting is done by all the external tools, and the LLM is just going to um, figure out in the context, in the output, what is relevant to be generated as an answer. But the holy grail would be your user types in a query, and then the LLM decomposes the query, and it calls appropriate external services. So it knows automatically that when you decompose a query into a few subtasks, subtask 1 should be sent to a Python interpreter. So and subtask 2 should be sent to an API, and so on. And where needed, so where needed means not, so some of the subtasks could be solved by the language model itself. It should be calling external services only when required, and then it combines all the responses into a coherent answer in the requested format. So we'll talk about the tools and models that facilitate this. So let's start with OpenChatKit, which is very, very new. In fact, when the language, so I'm recording this in a deferred fashion. When the LLM workshop was going on, this was not yet released. So it's pretty cool to see so much progress happening so fast. But that also means that this is pretty raw, and it's still a work in progress, and there seems to be a lot of work done to iron out the rough edges in future. So what does OpenChatKit component contain right now, and what has been released? So there is a 20 billion instruction tune model that is based on GPT Neo X, and it's trained on 43 million instructions. These instructions were collected from various data sources, and it's called the OIG dataset. Fun fact, I think I contributed one of the data sets to this dataset, just the raw one. But instructions were, I guess, automatically generated here. So then there is also an extensible retrieval system to integrate APIs. So there is pretty rudimentary right now. We'll have a quick look at it. And then a fine-tuning playbook for domain adaptation. So if you have your own, data, then you can use it for, fine-tuning this model. In general, I would recommend fine-tuning, not just fine-tuning, but also combining with the retrieval system in order to, make it more useful. And then finally, they come with a moderation model. So this is kind of, because this is not using reinforcement learning, how do you align with human preferences? So they have a separate model that, says whether a particular response or a particular query is appropriate or not. So you can, while you are using the OpenChatKit, you can send, queries. The moderation model can sit in front of this model, and then it can say whether this is an appropriate request or whether, it needs to be the model needs to say no, or whether there is toxic content and so on. So how does the Open Assistant? So this is the OIG dataset, the 43 million. So how is the format look like? So you can see the format is in the form of human and bot responses. So the human says, write me an article about Czech immigration, and then end with a sentence about Czech's Buenos Aires. So then the bot, it's basically, this is the data. This is the data in the data set, and this is the automatically generated instruction that comprises the data set. Another example is here. So you can see that there are very diverse set of instructions that makes this a pretty powerful data set. So I want to show you like a very quick retrieval example. So you can look at OpenChatKit here, and what they do here is they take Wikipedia index. So this is basically embeddings of the Wikipedia taken 3 sentences at a time. So every 3 sentences is its own embedding, and then they use a retrieval model to map your query to any of the entries in the index. And then if it is above a particular cosine similarity threshold, then they return it. And then they return also the sentences that are adjacent to it, so that it gets enough context. So you get adjacent W sentences to the match sentence if their cosine similarity is larger than a particular threshold. So now you can ask questions that whose answers are contained in Wikipedia using this. So this is pretty rudimentary, but it gives an idea about how one can fairly easily integrate external sources uh, for language models. So let's now talk about LlamaIndex. So LlamaIndex is a very useful library, and these are like some of the stronger aspects of it. So data connectors. So it allows you to easily use your data sources like Google Docs, Notion, etc. It allows you to build a wide variety of indices. We'll go into this a little more detail soon. And it allows you to parameterize your queries in very interesting ways. So what are the different types of data connectors available? So you can have web pages. You can feed web pages directly. I think you can also use another library in conjunction with another library. You can also use PDFs. You can get Discord data, you can get GitHub data, you can get Google Docs data, you can get Notion data, Twitter data. So imagine if your company documentation was all in Notion, and you want a language model to answer questions about your, you know, company policies or about even your product planning, etc. You just, if you have it in Notion or if you have it in Google Docs, you can just use the data connector and make it available to the language model. And you can build a whole lot of different types of indices. So let's look at each of them in a little more detail. So all these diagrams are coming from their own documentation. So the most simple one is a list index. So a list, how does a list index work? It's basically a sequence of um, you know document collections, I would say, or chunks. So let's say that you have a document that doesn't fit into the context of a language model. You just split it into chunks like this, and that's how you have this particular index. So when you have a user query in the default mode, what would happen is the first time it would take the data that is in node 1, or let's say the first section of the document, ask the question, and it gets a response. And now it takes that response, and then it takes the context from the second node, and then it says refine the answer. So it uses the prompt like refine this answer, and the answer gets refined. And then the answer is then fed here, and then with the node 3 data as context, and so on. The other option is using a keyword table index. So in this case, we use a large language model to extract keywords that are salient to your particular use case. So let's say node 1 in this case is, you know, has content related to NYC, and node 3 has content related to climate. And now then when a query comes, you also do keyword extraction of the query, and then you find which of these nodes has the information, and then you use these nodes as context to get your answer. You can also have a vector store index. So from my experience, I think this is the most, I guess, effective version. You generate embeddings for your data sources, and then you do a similarity match. So you do a similarity match with the query, and then if the most similar nodes, that data will now be the context for your model. You can also do tree index, and one exciting feature about LlamaIndex that has not been explored as much so far is the ability to compose indices on top of each other. But here, just looking at the tree index, so it's constructed bottom up. So you have node 1, node 2, node 3, node 4. But then the parent node is basically a summary of the child nodes. So now you can have something like a query go over the root node, and then it could traverse down to the edges based on the summary. So if you have your data in a hierarchical format, like a lot of data is, this could be a nice and effective mechanism. These are the next generation exciting indices. So you have the SQL index and the KG, the knowledge graph index. So the SQL index, it uses LLMs to convert from a natural language query to a SQL query. And in this particular library, it also provides support for automatic conversion from unstructured data to a database form. The same with the knowledge graph. So as I said, the queries are parameterizable. So you can say during the query, if a particular node has this particular keyword, then exclude it. Or if it only include nodes that have this particular keyword. You can have a compact form where it tries to fit as many nodes as possible in a single context window. The default is the create and refine, which is the one that I explained earlier. But there is also an interesting one called tree_summarize, where it constructs a tree during at query time, and it basically, that means it generates a summarized version of the output, which is pretty fascinating. So let's now then go to LangChain. So LangChain comes with a whole lot of utilities. So a lot of these features that LlamaIndex had is also available on LangChain, but I have just mentioned these as the features that LlamaIndex does better. So the LangChain features that are pretty useful are, again, ability to call a Python interpreter, bash shell, HTTP request, Google API, Google search, Bing search, SERP, which is again search engine API, and then Wolfram Alpha. So now things get really exciting. It provides something called as a chain, which allows you to compose different LLM calls. So here's the LLM math chain. Let's say that I have to do math, but we know that LLMs don't get math all the time. So what you do is you just call a Python interpreter from the LLM. So the way it works is you have a user query representing a math problem. Let's say, what is 15 times this? And then it generates the Python code. And then that Python code is then run on an interpreter, and you get the answer. And you can also customize the prompt here to ensure that specific libraries are used. Maybe you want this to be calculated in NumPy, or maybe you have some specific library that you need to use, or some specific rule to be followed. All of them can be placed in the prompt. There's the other exciting part called program-aided LMs. So where you can solve reasoning-based queries. So this is an example from the documentation. It uses a puzzle like this. So this requires arithmetic and logical reasoning. So what happens here is you do the task decomposition. So the language model does the task decomposition using the templated prompts, and then you end up with some mathematical equations that need to be calculated. So the Python code then is generated for doing the math, and then the Python does the math. So now, even if the LLM itself is probably going to fail at the math, you can just upload the math to the Python interpreter. And this is, again, exciting. And now it goes back to the initial use case that we talked about. So you have a natural language user query, and it gets converted to a SQL query. And then you run the SQL query, and then you format results into coherent answer. So for example, if we have a database of resignations, then we can just ask in natural language how many CEO resignations in 2021, and then you know in the prompt template we have to provide the database schema, the schema of the relevant tables, and you can also provide things like how many rows has to be returned. If you are asking to, if the question is containing something like uh, send me a few examples, then you can specify how much exactly needs to be returned. Or you can also look at how the rows look like. You can provide example rows in the prompt. You can also do API chains. So now again, going back to our initial use case, let's say we have a financial API. Then you have a user query, and it constructs API parameters and creates an API call. What was the lowest stock price of Apple in the last 10 years? So there are financial APIs providing stock price. And now if we put the API docs in the query template along with our um, key API key, you can actually now get the result. There is also LLM request chain. So if you want to just browse the web and get an answer, you construct a particular URL, use request library to call the URL. And for example, if I just want a weather in Toronto, I can get that answer. And finally, there is something called as moderation chain, where so currently LangChain provides the OpenAI moderation model. But you can imagine replacing this with a sequential chain to do anything that you want. So for example, if you have a model that detects PII, you can have it sit in front to ensure that the model is not spitting out PII to the user. If you have some way of fact checking things, then you can have it sit here so that the LLM, even if it uh, if it hallucinates, then the fact checker model can intercept it and give the answer, no, sorry, I am not able to find the answer, something like that. Yet another powerful feature of LangChain is called agents, and this is basically using task decomposition dynamically to figure out on its own which tool to use. So currently there are a few modes agents available, and you can create custom agents. So this is like the most difficult part of all it. And as I said, the most exciting field of research. How do you decompose tasks and enable the language model to correctly call the right tool to answer a question? So in this particular example, I think it's using zero shot. So that means it is just using the description of a tool to figure out which tool to call. So for example, I need to find out Camilla Moron's age, and it has a list of tools available. So just by looking at this and looking at the names of the tools, it figures out maybe I need to use search. And here, if it's something like I need to calculate 25 raised to the 0.43 power, then just based on the similarity of the thought and the different actions available, it just picks the calculator. So yeah, back to task decomposition. So I'm not going to talk about it here in detail because yeah, I think it's a totally different uh, talk on its own, and a fascinating one at that. But these are a few of the papers that are at the cutting edge of it. I think yeah. So finally, let's talk about um, what is in store next. So from what I see, the main thing, the game changer that we are going to see from these models is finally fulfilling the promise of cross-document information retrieval. Remember, this is basically when you have an information need, but your information need can be solved only by going through multiple resources. And current search engines are not a great paradigm for that, because they have resources of documents as first class citizens. Google, for most queries, gives you a list of documents, but we never, for most queries, unless we are actually searching for documents, for most queries, we are not looking at documents. We are looking at a answer with citations. And the language models of today are getting closer and closer to satisfying this vision. So at Bedrock, we have been doing this similar thing. So at our first iteration, we operated at the document level by having separate pages for filings. But we have been moving away from that. And again, it's in the same spirit. So finally, as I end the talk, I want to talk about something that I'm excited about. It's not something that we have planned to do yet, but whenever I find I have time, I would really like to make a language model be really good at a particular domain. So you have seen in the media saying that ChatGPT passed the medical exam, this exam, and all that. But for the most part, I guess it's easy to pass those exams. There is a lot of data contamination out there. It's those are not the good benchmark tasks. But what if you had a language model that you taught it from first principles, topic by topic, and building on it? And so I'm not a financial expert, but I work in a fintech company. So it's something that I have been thinking about, that I take, in future, take the CPA exam, but teach the language model along it as I learn it myself. It would be really interesting to see the limits of what it is able to learn and what not. But yeah, this is not a typo. This is actually the name of our domain adapted ChatGPT model at our company. So yeah, so finally, whenever I made a presentation about NLP, I used to use this slide to talk about why language is so hard. But now I think it has been finally put to rest, because I think I spent an hour the moment ChatGPT came trying to convince ChatGPT that John Cena caused a Make-A-Wish kid to have cancer, but it refused. So yeah, so that's that. Yeah, if